That your P1 inference endpoint, the one serving your main product feature, just failed to deploy. Not because your code was bad or your container was broken, but because the G5.x large GPU instance you requested wasn't available. A capacity error. All that work blocked by infrastructure scarcity. This is a preventable architectural failure, and I'm going to show you how. And most engineers either just retreat deployment, hoping for the best, or they massively over-provision on expensive, always available instances. Both are terrible strategies! This isn't just a convenience feature. It is an architectural pattern for building resilient, cost-aware AI systems. It's about trading rigid hardware dependencies for flexible, automated failover by design. So how do we fix this? We use SageMaker's capacity-aware instance pools. It's built on 3 core ideas. Number 1, prioritized instance list. Instead of requesting all any instance type, you provide a ranked list in your endpoint configuration. For example, first try the cost-effective G5.x large. If that fails, try the older G40x large, and as a last resort, maybe a more powerful P42x larger. Number 2, with automatic triggers. This isn't just for the initial deployment. SageMaker automatically works through your list during scale-out events and even during scale-in replacements. It's continuous resilience. And number 3, the most important part, decoupling the model from the hardware. This feature foresees you into the good practice of building model containers that aren't hard-coded to one specific GPU architecture. Your container needs the drivers and libraries to run on any of the instances in your list. Here's the workflow. It is incredibly simple. In your SageMaker endpoint configuration under production variants, that you define your model. Instead of a single instance type, you define an instance type alternatives list. That's it. First entry, your ideal price performance GPU. Second entry, your reliable, widely available fallback. Third, your break glass in case of emergency instance. Deploy it, and SageMaker's control plane handles the rest. No more manual intervention during a capacity crunch. Now, the caveat here is critical. This is not a magic performance bullet. Your fallback instances must be compatible with your containerized model. A model expecting ampere generation features will fail on an older GPU. You are explicitly trading consistent latency for high availability. Here's your starting point. Today, go to one of your existing single instance, type SageMaker endpoints, and just add on compatible alternative instance type to its configuration. Just one. Start building that muscle memory now. If you're building real-world AI systems, this is the kind of engineering that matters. Subscribe for more deep dives that go beyond the prompt. And let me know in the comments, have you ever been bitten by a capacity error?